Students, today we are going to do some of the conceptual questions of P block elements. Okay, so first question I have taken is white fumes appear around the bottle of anhydrous aluminium chloride. Why does it happens that yes, we see white fumes around the bottle of anhydrous aluminium chloride. Okay, actually see, these fumes are because of the production of HCl, that is hydrogen chloride gas. So here if AlCl3, I said, it is kept in a bottle, and we are seeing white fumes in it. Why? Actually this AlCl3, it reacts with the atmospheric water. It means the water present in the gaseous form in the atmosphere, and thereby it forms aluminium hydroxide, ALOH whole thrice. And here there is production of HCl gas. Just to balance it, and this HCl gas which is being produced, this appears as white fumes around the bottle of this anhydrous aluminium chloride. So understood this? Why we are seeing white fumes? Due to the production of this HCl gas. Now coming to the next question. Aluminium forms AlF6 3 minus, but boron doesn't form BF6 3 minus. Why? Both, when we see aluminium and boron, they belong to group 13. But what is the reason that yes, boron and aluminium, even though belonging to the same group, boron can't form BF6 3 minus, but yes, aluminium can form. So the first thing which comes in our brain is that yes, this for group 13, boron is the first element, isn't it? So first element of any group, if we take 1, if we take 2, if we take 30, if we take 14, all of them, what we are seeing that yes, it shows anomalous properties. Why? Because it is having too small size. And yes, if we talk about the size, so here you will be seeing that yes, boron having the atomic number of 5 and aluminium having the atomic number of 13. So naturally here boron will be seeing that yes, its atomic number is less, it is 5. So we can see it is 1s2, 2s2 and 2p1. You can see it is in the second subshell. When we talk about aluminium, it is 13. So here we see 1s2, 2s2, 2p6, 3s2 and 3p1. So some difference are you seeing over here? Here we are seeing it is in the second subshell. Here we are seeing that yes, it has entered the third shell, isn't it? In this boron, it is in the second shell, and in this aluminium, it is in the third shell. So here, second shell doesn't have any d orbital, but yes, the third shell has the d orbitals which are vacant. So the maximum, here we can see that yes, boron can have a covalence of 4 like we see in boron hydroxide. Here we can see it can be maximum of 4, the covalence. But in AlF6, here the covalency has increased to 6, and this is due to the larger size of aluminium which is having the vacant d orbitals. And as this aluminium is having the vacant d orbitals, naturally it can form AlF6 minus. And yes, boron, here size is too small. Maximum it can extend till 4. So this BF6 3 minus cannot be formed. Now coming to the next question. Why do boron and aluminium tend to form covalent compounds? Isn't it? Why? Here if we are saying both boron and aluminium, they both will have 3 electrons in its outermost shell. Boron having the atomic number of 5, aluminium having the atomic number of 13. So here we are saying that yes, these two, when we talk about this boron and aluminium, its size is too small. Because you know what, that yes, if we go from left to right in the periodic table, what happens? The electrons are added to the same shell, and as the result, what happens? The effective nuclear charge acts more, thereby tending to make the size of the elements smaller. So here we are seeing what? That in boron and in case of aluminium, as they are having small size, electrons are held or bonded effectively with the nucleus because of the effective nuclear charge. This effective nuclear charge of the nucleus of these two elements, what they pull the electrons towards itself, making the size smaller. So if the size is too small, and yes, the electrons are to be removed. How many electrons are to be removed from the first shell? That is from the last shell, sorry. It is 3 electrons. So these some of the ionization enthalpies which it will come, it will be too high. So instead of forming the ionic bonding, they tend to undergo the covalent bonding, thereby forming the covalent compounds. Now next question. Boron hydrides exist as dimer, that is B2H6, but its trihalide exists as a monomer. Why does this happen? If this is boron hydrides are existing as dimer, then why the trihalides are existing as the monomers? Actually what happens when we talk about hydrogen, its size is too small, only 1 electron is present in it. But when we talk about the halides, we are saying the number of electrons are more. And yes, when it is forming the bond, it can occupy these hydrogen atoms. But yes, when we are talking about the halogens, halides, here it is boron this chloride, example which I have given, it is a trihalide. Here what happens, as the size is more of the halogens or the halides, what happens, this boron being too small in size cannot occupy or cannot accommodate this 3Cl atoms of this element of chlorine. Thereby it can only form a monomer rather than a dimer. So now students, coming to the next question, next conceptual question or the reasoning question you can say, why does AlCl3 exist as a dimer? Actually this AlCl3, when we are saying, aluminium, forms the bonding with chlorine, aluminium valence electron, if we see, it is how much? 3, isn't it? So if we are seeing 3, so what happens over here? What are you seeing? Is its octet complete? No. It is not complete. Only 6 electrons are there, isn't it? So even though combining with chlorine also doesn't complete its octet. And as a result, if it is not completing the octet, it means it is unstable still, isn't it? So what happens? Here we see, as this is an electron deficient compound, what happens here, in order to fulfill this octet rule, okay, it forms a dimer. Now you see, Al, okay, having what? 3 electrons, okay, Cl, Cl, okay, Cl. Next aluminium, okay, sorry. Next one is here, you can see it forms Cl. This Cl which you are seeing, okay, here you will be seeing that it forms a coordinate bond over here, okay, and here in this you will be seeing this forms a coordinate bond, naturally fulfilling the octet rule. Thereby this AlCl3 exists in the form of a dimer rather than the compound like AlCl3 forming simple this covalent bonds. Okay. Now coming to the next question. Aluminium is electropositive metal. Even then it is used as structural material. Why? Why do we use it to make different materials? If it is electropositive in nature, it will be reactive in nature, isn't it? But yes, then also we may make the materials from aluminium. Why? Actually this aluminium, what happens, as it is electropositive metal, okay, it will react first with the oxygen of the air, okay, to form what? Aluminium oxide, okay, it will form what? Aluminium oxide. And as soon as this aluminium oxide is formed, a layer is formed on the aluminium metal. Thereby what happens, this is a tough layer, it cuts this aluminium from any other substances, okay, because this is too durable in nature and it makes it what? Unreactive in nature. So further reaction becomes very, very difficult, and as the result, and if it becomes very, very difficult, it will not be reactive, and yes, if it is not reactive, it can be used in making the structural materials and number of things which we see in the market. So hope students, 6 questions we have discussed today, you might have understood it. Good day, take care.